Hi, I'm Mr. V, and this is Illustrative Mathematics, Unit 1 for Geometry, which is on constructions, and later we'll discuss rigid transformations. And this is Lesson 1, which is about build it. It's about using some fundamental construction tools. The objectives: I can create diagrams using a straight edge, and I know how to use a compass to construct a circle. So the first thing I asked is your mood. Are you energetic or tired? Are you positive or are you negative? Next, we had to match some things. And there were three pictures here. One was the double line, one was the circle, and one was this segment. Well, the parallel lines is the two lines. If you move the square over to the other, on top of the other square, they match up. These are parallel lines. They do not intersect in a plane. They have the same slope. So a set of points equidistant. Let's see, where is this? A circle. And here we have a line segment. A line would continue on forever and ever. A line segment has one dimension, and that is length, and it goes from an end point to an end point. The set of points that creates the shortest distance between 2 points. My wife teaches art, and she says that curves are line, and that's not the same in geometry. In geometry, that's the shortest distance between 2 points. Lines in a plane that do not intersect. Notice it has to be in a plane. If you had the floor runner of your floor and you had the top piece here, these are two lines not in a plane that do not intersect. Those would be called skew. That's all I will say about that. Finally, we have this definition of a circle. It's a set of points that is equidistant from the center. What do you think equidistant means? What does it sound like? Equal distance? Yeah, that distance is the radius. So it's equal distance from a given point. That set of points is the definition, and this will be on your first test. So make sure that you understand and know this definition of a circle. First, you were asked to draw this using by freehand, using the tools that were provided, and several people you can see did this here. I will anonymize their names so that you don't see their names. The constructions. In this construction tool, there's a video that explains how to do it. The purpose of this was to get to know and get familiar with the construction tools. The construction tools we will use in GeoGebra are very similar to those used in Desmos, so we'll use them both. For the first 2 weeks, that's about all that we're doing is drawing and making constructions and finding out the difference between freehand and a construction of an object. So this is a video that helps with that. Here are specific instructions on how to do a certain task, and there's also a video which shows you how to do that. On this page, what's the difference between the first attempt you came up with and the straight edge and compass tool? The straight edge and compass tool fixes the circles in place so that they cannot be moved. It's dynamic. You can make the whole thing larger or smaller, or you can move things around on a circle, but they're attached. And they're attached in such a way that they are rigid, and also they look pretty, so as opposed to being free-handed. We have this warm-up tool that I give you. This is the several puzzles, and there's a short demonstration on how to use YouTube, how to use a YouTube presentation on how to use GeoGebra, and you can watch this. The tools are very similar to those in Desmos. If you've done the Desmos activities up to this point, you'll know how to do a lot of this. I'm going to show you the way that this looks. First of all, there's a task overview. If you look at these puzzles, the very first thing, given a line segment, AB, draw a circle with its radius as the line segment. So I'd use the circle tool. I only give you a limited number of tools, so you don't have access to all of them. And when I make this through point B, you can see that as I do a drag test, point B can only stay on the circle. It's a set of points that are equidistant from A, that is from A to B. And further, you can see over here, there's the next one, and there's more. There's other tasks. There's 17 tasks, and they start off pretty easy, and they get harder. The object isn't for you to know how to do all of this. It's for you to explore the tools and to learn how to and become familiar with the tools by exploring with them. By the end of this unit, you will be able to do all of these constructions. But for now, just try them out, see what you can do, see what you can come up with. Here's a GeoGebra activity that we had. This is about illegal moves, and I will show you how this works. You will do this on your own. The first thing is we have to draw a circle. And you could do this also in GeoGebra, in Desmos, using slide 11. It does the same thing as this dynamic GeoGebra applet does. So the first thing I'm going to do is I'm going to draw a segment. I want to make this smaller. I'll draw a segment AB. A circle AB goes through B. I'm going to draw, we're going to estimate where point C is. And see, it looks like it's at the midpoint. I want it to be at the midpoint. And I'll label that point C. So I come over here to the gear tool. Excuse me, I need to select the point. Select the point, and now I'll select the gear tool and change the point name to C. And I'll show the point so you can see that this is point C. I want to draw a circle, and it looks like this through point C. This has two intersection points, one at the top and one at the bottom. So I can draw a line through that or a segment. I'll draw a segment through it. I'll also label those points as D and E. So this point, we'll use this tool again. I'll label it point D. Show the label. And I'll label the bottom point, point E. Select it and change its name. And there we have it. Now I can draw this polygon with around this. You have to end where you start in order to finish it. So I'll end at point E, and this is the polygon. And the question was, which you'll see in a moment, can you do a drag test on this? Well, these don't drag. The only one that drags is point C. And you want to know, is 2 of AC equal to AB? And if this were the midpoint, that would be true. But the fact is that this is dynamic, and 2 of AC here is not equal to AB. So you can see that this is different. This is strange, the way that this works. That's because it was not constructed. It was free-handed. And that's what the whole point of this exercise was. So you can see two different people got two different things. Where did it break down? It broke down in this one. Estimating. By freehanding, you are not constructing. And that's when it all breaks down. So we want to be able to construct the drawings. Is this true? No, it is false, because this is free-handed, and so you can move it around. It would be true if this were the midpoint, if it were constructed as a midpoint. So writing that AD and AE are the same, that's true because they're both radii of the same circle, circle A. And the radiuses are the same. Now, why do valid, straight, edged, and compass moves guarantee everyone will produce the same construction? It's because they are constructed, they are locked in, they are, it's dynamic so that you can move things around, make them larger and smaller, but they are locked into place if they are constructed properly. So a square would stay a square. It would not be able to, you can do a drag test, it would not fall apart on you. So here's another one, which is a more perfect copy one. This is yet another GeoGebra activity. And the first thing you do is you draw this with a marking tool, like a pen. You try to draw this, and you do not get a very good result, which students end up with something that looks pretty good, actually, but not perfect. Some people tried to draw this just drawing it by making a circle over here. Well, I'm using the tools that I've got. I'm using this distance is the same. This radius is the same for this circle as for this circle. And this circle is this is the same. I could actually make an equilateral triangle out of this. I could make several circles using this compass tool, using this radius, and using the new center. So I'll use this radius and the new center. And when I go around the circle in this manner, you can see that I'm using the compass tool. I'm coming up with a daisy chain, like several of these circles that look the same. I think I got one more. Put it right here. And now, when I connect these, you can see that they're fixed in place. They're not going to move. Oops, I need to select this tool, polygon tool. And you go through each of these, and now it's going to be exact. It's going to be the same. Why? Because I started off with the same radius as this length, and I've constructed. If you try to do a drag test, the things stay in place. So good luck with that. Mostly it's about exploring. Here, create a circle centered at C, whose radius is the length of AB. So when we construct, we're going to use more tools. We're going to use the compass tool, which is more tools. And we'll select this is our radius, and this is where its center is. Mark a point on the circle and label it D. So if I take a point and I have to mark it on the circle, I will label it by selecting it, clicking on it, label it point D, and draw line segment CD. So I'll go back to construct. I will draw segment from C to D. There it is. Oh, I have to draw the line CD, sorry. And I'm going to draw its other intersection over here as point E. And I can label this. And now you have it. This distance is the same as this. This distance of this diameter is 2 of these radii. Here's a summary of what we've talked about today and the debriefing to show me what you've learned and how well you've understood what we've done. So good luck and success.